Hello and welcome to the new lecture session of modern vehicle technology. This is the subjects of automobile engineering department. For today's section, we will discuss new topic, that is fuel cell. So students, let's start with this fuel cell. Fuel cell is an electrochemical device or is an electrochemical cell which converts chemical energy into electrical energy. Basically, it is produce energy from chemical reaction into electrical reaction. It combines hydrogen and oxygen. It combines hydrogen and oxygen to produce electricity. Beside the electricity, water and heat are the byproducts of the fuel cell. This fuel cell for the fuel cell, the basic fuel is hydrogen, and as an oxidizing agent, oxygen is used. So hydrogen is the main basic fuel, and besides this, oxygen is also required for this fuel cell. After the combination of these two chemicals or two gas, hydrogen and oxygen, they produce electricity. So this is the basically fuel cell. Next comes to the history. In the year of 1838, Sir William Grove, the first person who invented the fuel cell. In the year of 1838, Sir William Grove was the first person. Sir William Grove was the first person who invented the fuel cell. Here in this picture, this is the picture of Sir William Grove, and this is the picture of his invented first fuel cell. Here they use sulfuric acid solution, water, and in this factor they invented the fuel cell. So this is the basic history. Now comes to the timeline of the fuel cell. In the year of 1801, Sir Humphrey Davy demonstrated the principle of fuel cell. As we know, in the year of 1838, Sir William Grove first invented the fuel cell. Before William Grove's invention, Sir Humphrey Davy in the year of 1801 demonstrated the principle of the fuel cell. After the demonstration, in the year of 1838, Sir William Grove invents the first fuel cell with the help of the principle of fuel cell by Sir Humphrey Davy. After invention of fuel cell by Sir William Grove, in the year of 1889, Charles Langer and Ludwig Mohn developed the first fuel cell. Basically, it is after a half century of invention, first fuel cell was developed by Charles Langer and Ludwig. After the year of 1889, then it took long time to invent new type of fuel cell. So in 1950, proton exchange member fuel cell or PEMFC was invented by General Electric. After the 1950s, in the year of 1959, alkaline fuel cell was demonstrated by Sir Francis Bacon. So Francis Bacon first demonstrated the alkaline fuel cell in the year of 1959. After the first demonstration of alkyl fuel cell, the next year, means in the year of 1960, NASA first used the fuel cell in their space mission. So basically, after invention of alkyne fuel cell, this was used as a fuel cell in space mission under NASA in the year of 1960, first time. After that, in the year of 1970, Cathode builds the first fuel cell car. In the year of 1970, Cathode builds the first fuel cell car. Then, in the year of 1993, Ballard Power System launches first proof of concept hydrogen fuel cell bus. In the year of 1970, first fuel cell car was invented by built by Cathode, and in the year of 1993, hydrogen fuel cell bus was first proof launched by Ballard Power System. After the 1993, in the year of 1996, Daimler-Benz and Toyota to unveil prototype fuel cell powered passenger car. So, fuel cell powered passenger car prototype was unveiled by Daimler-Benz and Toyota in the year of 1996. After that, in the year of 2001, Honda opens first production and fueling station in Torrance, California. So, Torrance is the city of California where Honda first produce and opens a fuel station in year of 2001. So this is the basic timeline of fuel cell. So it comes to 1801, then 1838, then 1889, then 1950, 1959, 1960, 1970, 1993, 1996, and 2001, and so on. So this is the timeline of fuel cell. So come to the next slide. So after completing the procedure, the next is construction. So after knowing the working principle and their procedure, so we need to know about the construction of the fuel cell. To construct a fuel cell, 4 parts are more important: anode, cathode, electrolyte, and catalyst. In the diagram, this is the cathode, this is the anode, this is the electrolyte. So let's start with these 4 parts and describe elaborately. First one is anode. Anode is a negative post of the fuel cell. Anode is the negative post of the fuel cell, because every fuel cell has 2 posts, one is positive, another is negative. So the negative post is known as the anode. It conducts the electrons that are freed from the hydrogen molecule so that they can be used in an external circuit. Anode basically conduct the electron, and from where electrons comes from, electron comes from, basically it freed from the hydrogen molecules. So hydrogen molecules freed electrons freed from hydrogen molecules, and that electrons, that the division of the hydrogen is held in the anode, so it can be in the external circuit. After that, each channel displays hydrogen gas over the surface of the catalyst. Each channel displays hydrogen gas over the surface of the catalyst. So this is the physical anode. Next one is cathode. Is the positive post of the fuel cell. So as we know, every fuel cell has two terminals. One is positive, another is negative. So negative portion is known as anode, and so positive portion is known as the cathode. So cathode is the positive post of the fuel cell. Here each channel distributed oxygen to the surface of the catalyst. In the cathode, each channel distributes oxygen to the surface of the catalyst, then conducts electron back from the external circuit, and the anode conduct the electrons back from the external circuit to the catalyst, recombine with the hydrogen ion and oxygen to form water. With the help of anode, hydrogen is divided, hydrogen plus ion and electrons. Then electron goes to the outside to the external circuit. That electrons come back to the cathode from the external circuit, and hydrogen is met with the oxygen and produce water. So this is the working method of the cathode. So after going over the cathode, let's go to the slide. The next slide is based on electrolyte. Basically, in here proton exchange member is used as an electrolyte, which is specially treated as material only conduct positive charged. As we learned earlier, previous. So in the previous slide, we learned that hydrogen fuel is checked on anode, and there it divided into hydrogen plus ion and electron. So after the division, just because of electrolyte collect the positive charge, so they can only accept the hydrogen plus ion to enter the electrolyte, and rest the electrons which is moving around the electrolyte. It was with the help of the external circuit. So membrane allowed only positive charged, not the electron. So this is the basic thing of the electrolyte. Next, catalyst. Special material that facilitates reaction of oxygen and hydrogen. Usually platinum powder very thinly coated onto carbon paper or cloth. Platinum powder very thinly coated onto the carbon paper or cloth. Rough and porous maximizes surface area exposed to hydrogen or oxygen. Rough and porous maximizes surface area exposed hydrogen or oxygen. The platinum coated side of the catalyst faces the PEM proton exchange membrane. The platinum coated side of the catalyst faces the proton exchange membrane. So this very catalyst is used to facilitate the reaction of oxygen and hydrogen. In normally platinum powder is used for the catalyst. This powder very thinly coated. This platinum powder is very thinly coated onto the carbon paper or cloth. The platinum coated side of the catalyst faces the PEM or proton exchange membrane. So students, these are the four parts which is needed to construct a fuel cell: anode, cathode, electrolyte and the catalyst. After knowing the construction of fuel cell, next is types of fuel cell. Basically there are 5 types of fuel cell. First one is alkyl alkaline fuel cell or AFC. So first one is alkaline fuel cell, AFC. Second one is proton exchange membrane fuel cell or PEMFC, proton exchange membrane fuel cell. Third one is phosphoric acid fuel cell, PAFC or phosphoric acid fuel cell. Next is fourth one is molten carbonate fuel cell, MCFC, and next one is solid oxide fuel cell, SOFC, solid oxide fuel cell. So students, these are the types of fuel cell. So from today's lecture session you can learn about the fuel cell, definition of fuel cell, basically its working nature, its convert the chemical to electrical. Then next is its history. Next is history. Then we will learn about the timeline of the fuel cell. After that we will learn knowing the working principle of this fuel cell. Beside the working principle, we will gathering knowledge about the procedure and construction of fuel cell. And we all know right now, we will know about the types of the fuel cell. In the next lecture session or lecture session 2, we will discuss the types of fuel cell elaborately. So still down, stay safe and stay healthy in your home. Okay, thank you student, thank you so much.